All right, good afternoon, everyone. Uh-oh, that's good, it's working. So this is a session on React.js, of course, for web programming. How many people are currently using React.js? Anybody? Oh, okay. You're probably not in the right room. This is a fairly introduction to React.js. But if you already build React, maybe you'll learn something, right? If you don't, you're in the right place. So real quick about me, my name is Pratik Patel. If you have any questions or follow-up after this session, you can reach me on Twitter at @prpatel. And I also do these other things that are on this slide. So don't waste any time and get right into React. So React is a UI-only library. It is developed by Facebook, and it runs things like Instagram and other things. But there are a lot of different people, aside from Facebook, who use React. It's quite popular in the web development community. I would say that Angular is still the most popular framework, and then React is the next most popular framework. And currently, the third most popular framework is a library called Vue.js, which I think there's a talk on Vue at this conference. Is that right? Yeah. Is that already happened? Okay, never mind. But anyways, it's one of the top three popular frameworks. And one of the interesting things about React compared to something like Angular is that React is a UI-only library. It doesn't really provide you with much except for just doing the UI componentry. Okay, so you build components with React, and we'll get into an example in a minute. But you build components with React, and once your application gets a little bit more complex, and once it goes from simple to being more complex, you have to typically add in some extra libraries to essentially architect a full, complex front-end application with it. And we'll talk about that towards the end, and give you some idea of what people in the community are using to build anything beyond simple applications. So let's dive into some React.js concepts first, and then we'll do some live coding. And if you have any questions while I'm coding, please feel free to ask. We can try some stuff in the editor. So one of the first things from an architectural point of view about React is that it is what we call an isomorphic framework. I think the current jargon for isomorphic frameworks is SSR, or server-side rendering, or universal applications, right? So the idea is that you can write your code that is normally meant to be run inside of the web browser and only in the web browser, but you can actually also execute your code on the server and send up what we call pre-rendered components to the web browser. So the web browser has to do less work. You do the work, or you do the heavy lifting on the server as opposed to doing it in the web browser itself. Right? There are some good use cases around that, which we'll discuss shortly. But the basic premise is, when we typically think of writing a web application, we think of everything being running almost entirely in the browser. Right? So you create a bundle, or you have some tooling that creates a bundle or some JavaScript. You have your HTML and CSS and all that, and you ship that up to the user, and everything runs in the browser. With isomorphic or universal web application frameworks like React, what you can do is you can actually run that code on the server if you want. You can run everything on the server, right? So there's some stuff still gets sent up in terms of JavaScript up to the browser, but if you want to do a complete render on the server for your application, you can do that, right? And so the use cases around that are performance, search engine optimization. If you have very heavy widgets, you can render those on the server instead of rendering them or pre-rendering them on the server instead of rendering them in the browser. And also, we have this possibility that we can have the code run some on the server and some on the browser. Right? So a good example of this is what's popular, or what's kind of a popular architectural pattern around this with React and Vue.js, for example, is you'll do your initial rendering of components. So when the user first comes to your website, you'll do a server render of them so that when the user comes to your website or your web application, it takes less time for the application to start up. Okay, so React allows you to do this. Right? So you build the initial shell, you run all the code on the server, and you send up what the user will see initially as pre-rendered components, and React activates those components in the browser without having to do all the work and all the construction in the browser itself. Right? And this is commonly referred to in the web world as bootstrapping. Okay? There are lots of different concepts here, but universal rendering, allows you to do bootstrapping so that the web browser has to do less work when the user first comes to your website, and that's specifically called bootstrapping. Okay? So one of the great things about React is that with this isomorphic framework, it gives you the possibility as a developer to have a huge amount of flexibility and to do low-level performance management of your application. So initially, you don't need to do this stuff. You might have a small application, but as you add features and your app gets bigger and bigger and you have lots and lots of different widgets, you may want to consider going down this road. All right, so we've talked about universal rendering or isomorphic rendering or server-side rendering, right? Those terms can typically be used interchangeably, but that's not the main reason why React is fast. So React mainstreams something called the virtual DOM. This is a specific bit of technology that is internal to the framework and allows the framework to run extremely fast in the browser. And what the virtual DOM does is it actually does a snapshot of the physical DOM, right, the DOM objects that are actually there, the body tag, H1, tables, etc. And it takes a copy of those in JavaScript objects, and it keeps that copy underneath the actual components that you write. And as you instantiate components and you attach them into the view at wherever place you have them, the virtual DOM acts as a buffer or an optimization layer underneath. So if you were to go and create some H1 tags, or as you'll see in a few minutes, we'll create like some LIs, etc. What the virtual DOM does is once React figures out that you have finished doing your updates and instantiating new objects and attaching them into the componentry that React creates for you or you create in React, it looks and sees what actual changes need to be applied and doesn't apply everything because some of those changes may already be there. And that's what smart diffing is. So it says, okay, you want to go add these 4 table rows, but 2 of them already exist. So I'm not going to add those 2 table rows back in because they're already there, for example. It could be anything that you have in the view. It doesn't have to be table rows. It could be an H1 tag, whatever. Right? The other thing it does that helps performance is the virtual DOM batches the updates. So if you've been programming web applications for a long time, we used to do stuff like this manually. Right? What we would do is, okay, I'm going to go get some JSON data from the server. I have 50 rows that I need to show, 50 rows of data that I need to show in a table or something. Right? The absolute worst thing you can do is grab one of those things in your JSON array, construct some HTML, put it into the view. Get the next thing, construct some HTML, and put it into the view. Because every time you do that, you're forcing the browser to do a lot of work. And what React does for you is that it senses when you finish making updates, and it takes all the changes that you've asked for, and it pushes them into the DOM all at once. So it batches those updates so the browser has to do less work. Okay? We'll get into that for a few minutes. So and other frameworks use virtual DOM. For example, Vue.js has its own implementation of virtual DOM, and Angular does similar tricks to have, or the new versions of Angular, like 4 and 5, do similar tricks to get like really good performance in the browser. All right, so we're going to skip the jokes for now. We'll come back to those later. All right, so when we think of why does the virtual DOM work so well, and why is this such great technology, and why does almost every web framework today implement this? We have to think of a typical browser update. Right, so when you give the browser some HTML or some CSS or whatever, whether it's the first time you do it or if you're doing an in situ update, i.e. doing an update into the view, the first thing that the web browser has to do is it has to parse the markup and the CSS. That means it has to take those strings, the text that you pass it with your H1 tag and your body and your P, etc. It has to take those and it has to parse that and construct DOM objects or native DOM objects from it. Similarly for the CSS, when you give the browser some CSS, it has to go look at that CSS text that you passed it and it has to construct browser objects from it. So that's the first step in a typical browser update. And again, we're talking about what's a typical browser update when you give a browser some stuff to do, right? An update or initial render of your application. So once it has parsed that, it goes and creates a render tree. That's essentially going and creating those DOM objects and saying, okay, you added an H2 at this specific place, so I'm going to go and attach, I'm going to create a DOM object that represents that H2, with the text inside of it and the stylings with the CSS, et cetera, and has to go and then put it into the render tree after it's instantiated, right? Because you can think of a website or a web application as essentially a tree of DOM components. You start with the document object, and then you have your body, and inside of that you have a H1, et cetera, et cetera. So you're basically creating a tree, or the browser is creating a tree internally that represents your specific web page. All right, so we parsed the markup, the browser's created the render tree. The final step that the browser has to do is has to do a reflow and repaint. So a flow or a reflow is the browser figuring out exactly where in the view that component should live. How big is it? How many pixels wide is it? Right? Where does it fit in relation to the other elements around it? And if you're familiar with browser programming, you know that the browser is a flow-based layout manager that starts at the top left, fills in, quote-unquote, one row of data, and then fills in another row, and you scroll infinitely down depending on how much content you have. So it has to figure out exactly where everything is positioned first. And once you've figured out, or the browser's figured out where it's positioned, it actually has to take that and paint it onto the view, or into the tab, the browser window, so that the user can see it. Okay? So there's usually like about 10, depending on the browser, 10 or 12 discrete, or maybe 15 discrete steps, but these are the three major steps that every browser has to do to show some update, or first time it does a render of a view. Now, the first two steps here are actually very fast. Right, the browser optimizations, right? It's great having all these different browsers because they're pushing forward the envelope in terms of browser performance, and the users benefit and developers benefit as well, because we don't have to worry too much about low-level performance nowadays with frameworks like React, and browsers are very good. But what we want to do is we want to avoid doing that last thing, because that's the most expensive thing when we go and build a web application and we need to add stuff or update the view, show some new data, whatever it may be, right? So we want to avoid doing reflows and repaints as much as possible. What triggers a reflow and repaint? Well, anytime you update a DOM, anytime you do a DOM update, if you hide a DOM node, that triggers a reflow and repaint. If you move or animate a DOM, reflow and repaint. Do some style changes, change some CSS, that triggers a reflow and repaint. So these are the things we want to avoid to get the best possible performance out of our browser application. So the virtual DOM manages all this stuff for you, right? So back in the days when we used to write straight HTML, or maybe you use jQuery to do stuff, we had to think about these things manually, right? So if you go back to the previous example, I get 50 rows of data as JSON from my server, and then I take one of those rows, and then I create some HTML, and I stick it into the browser. Right? I go get the second row, and I stick it into the DOM. Right? So what we used to do is we used to go and say, this is probably not a good idea, doing it one by one. We would just traverse the entire data set of 50 items that we want to show. We create a massive chunk of HTML, and we plug it in one time into the browser instead of doing it 50 times. Because again, what we want to do is avoid doing the reflow and the repaint multiple times. That's when the user notices that the browser, your application is running slow. So we want to avoid doing that. And the virtual DOM in React manages that for us. It manages the DOM state. So all we have to do as developers is just create React components and attach them into our component tree, and it handles everything else for us. It helps us avoid the reflow and repaints multiple times, and it batches the updates. It does a diff to make sure we're not pushing in updates that already exist, et cetera, et cetera. Okay? So we do smart diffing of the DOM, reduce the number of changes to be applied, and reduce the number of reflows and repaints by batching everything together. And the great thing is as a React developer, you just need to know that this is how it works, and that's it. You basically just build components, write components, instantiate components, and the framework takes care of all this low-level performance management for you. Okay, but it's interesting to know this so that you understand. And one thing that you have to know is that when you're programming in React, that because we have this virtual DOM layer between our components we instantiate and the actual DOM, you can never reach under the virtual DOM and make a change directly to the DOM. That's very bad, right? Because what happens in that case? If you reach under the virtual DOM and directly manipulate some CSS or HTML, what happens? Your virtual DOM is now out of sync with what's actually in the browser, right? And there's actually a way to do this. There's a function in React called dangerously set inner HTML. Okay, I'm not joking. That's what it's actually called, right? So you should avoid doing that as much as possible. There are some edge cases that require that, but in the time that I've been doing React applications, I've never actually used it. Okay, so let's get into some React basics now that we've covered some of the architectural things around it. And I'm going to jump into my code editor here and try to do this. Let's make this font a little bigger. Okay, so we have our simple hello world application. And you have to remember that React is a component-based architecture, right? So what I have here on the screen, looks big enough. Does that look big enough? Yep. What I have here on the screen is I've created a React component here, and it's just called hello world. And typically what we do, we'll get into some more of the life cycles, but typically we'll put our HTML inside of a render block, like so, okay? And, ooh, that's not good. Hope that doesn't keep popping up. Okay, so we have a render block here, and inside of the render block, in this specific component, I have our return block, and in this case, our return block is just putting in some HTML-like tags. Actually, that pretty much is HTML. So this specific syntax that's highlighted here is what's known as JSX, okay? And you can see from this code that we're mixing what looks like HTML tags with our JavaScript, like literally in the same block of code. So some of you were like, well, this looks a lot like PHP. Have we taken like 3 steps back? What's going on here, right? Sorry, with apologies to PHP developers if there are any here. Right, it's like, have we taken a step back? Or everyone in here is probably a Java developer. Is that about right? Yeah, okay. So did anyone do web programming in the fun days of JSPs? Right, yes, okay. And then eventually, after your web application in JSPs got complex enough, you always had that 8,000-line JSP file that nobody wanted to touch because you never knew what would break if you did that. Yeah, you're laughing because you've done it, I know. So I used to do it. I was like, oh, there's got to be a better way than this. But anyways, so it's like, whoa, have we taken a step back? What's up with this? Why do we have JavaScript code mixed in with HTML tags? And so for a long time, there was a movement or in our developer community where, oh, this is bad. We can't mix, because we all got burned by JSPs. We're like, this is bad. We need to separate out our markup and put it over here and have our JavaScript over here. And we thought that we were separating concerns. And a lot of frameworks, if you built in like other frameworks, like if you used Wicked or Struts or whatever, they try to enforce this strict separation between your markup and your actual JavaScript code. But in fact, that was probably not the right thing to do, because what we want to do, especially when we're writing React, is we want to create a fully encapsulated component. We want to have cohesion between our code and the actual markup that our code is going to manipulate. So it actually feels quite natural to have this, what looks like HTML or JSX, along with our JavaScript code, because now what we're doing is we're creating a fully encapsulated component that lives in one file. So I don't have to go and touch 3 different files to go make changes. It's everything for that component is in one place. All right. So some rationale behind that is we have our Hello World app here. So let's go show, you can see I have a date here, and you can see I'm writing in ES6. So let's go create an H2. I must have done something. I don't want that to keep popping up. That's going to be very annoying. Well, I'll try to keep it in the right corner. Okay, so say we want to show that date. We have now here, right? So let's just go and put that in. So one thing we can do, yep, that's not going to work. Sorry. Let me, let's switch to something else. My apologies. We'll get this sorted out in just a second. It's behind here. There it is. All right. Yay. Okay. New window. Where did it open it? Oh, there it is. Okay. Oh. Yes, no, maybe. Stop indexing. Okay. My apologies. Let's get back to where we were. Okay, and let's make this bigger. There we go. All right. How do you stop this from indexing? Oh, you click this button. Okay, there we go. Now we can actually do stuff. All right. So we have our component here. Let's make sure this works. Demo gods are not being kind to me today. I apologize. All right. Yep. A little bit too much deletion there. Let's try that. There we go. Okay. Woo. Back on track. All right. So let's say we want to show this date. When we want to just use some JavaScript directly inside of our JSX, what we do is we put curly braces around it, and we go and basically take that JavaScript object, string, whatever it may be, and go and show that. So let's go save that, and oh, something didn't work there. What happened? Interesting. Let's go look at our output here, and let's see what we broke. Okay, this all looks good. Did I miss an H2 tag? No, we'll do that in a minute, okay? So this is a little JavaScriptism. JavaScript is fun because there are lots of edge cases for lots of different things, right? I'm being sarcastic, by the way. So what's the issue with this? What do you think? Why is this not working? I mean, the data's there, obviously, right? So if you know your JavaScript well enough, you know that the date object in JavaScript does not have an implicit toString when you try and go and get it. So what we have to do in this case is we have to just do now dot toString, all right? And now we should be able to get a date. There we go. Now we have a date, okay? So a couple of little things you have to know. In this case, what happened is that specifically when we try to look at a data object in JavaScript, because it doesn't have an implicit toString around it, React says, you've just given me a JavaScript object, I don't know how to render it. Okay, if we looked at the console, it would basically tell us that. It would give us, I think, an invariant. So let's go have a quick look. And let's do inspect. And then we'll go into our console. Let's take this out. Let's break it again. Let's go save it. And then if we zoom in here, you'll see that React is complaining that objects are not valid as a React child, right? So it's basically telling us that I don't know how to render this object you've given me. I need a string or something to show to be able to show it to the screen. So you have to make sure that you pass something that React or in plain JavaScript can be rendered into a string. That's what we've done here. All right, so we have our basic component here. Let's go add some extra stuff here. Let's make this a little bit bigger, if I can get this out of the way. All right, and let's go and let's say we want to show some data. So for now, we're not going to go pull any information from a server. We'll just say, what are our lunch choices for today? And what do we have today? I think we had beets, and maybe if you're a vegetarian, there was a second vegetarian option, and yesterday we had some fish or something. Okay, so here's our lunch choices. How do we pass data into a React component? Right, because components are supposed to be encapsulated like freestanding things that we instantiate and then put into the view. So in this case, I need to pass what our lunch choices are going to be into this React component. And the way that we go and do this initially is we have React DOM.render, and we say, this is our initial component or a root component that we're going to mount into the view, and we're going to mount it at this specific place called document.getElementById. And if we go look at the index.html that's kind of backing this, you'll see that it's not actually very fancy. You can see we have a place here where we're going to mount our React application into the view. Okay, so we have a div, id equals root. If we go back to our source code, you can see I'm saying React DOM, do the render of our component, i.e. mount our React application with the root component as hello world, which is this guy right here, and say document.getElementById root, so that's where it basically sticks our React application into the kind of the HTML and the web components around it, okay? But we need to pass this in. So what we do is we say lunch choices. This is the name that will appear on the inside of the component. And again, you can see I'm using curly braces because I'm referencing some JavaScript inside of JSX, right? So you can see I have, this looks essentially like an HTML element, okay? So now I have lunch choices here. Let's go and let's create an h2, and we'll do this dot props, right? So what we've done is we've created a property, right? When you pass in something that looks like an HTML attribute into a React component, we're essentially using what are called properties. So this is how we construct React applications. We use properties and we use something called state to construct and build a real-world application. Okay, so let's try this. And of course, I have to surround this with curlies. So let's go save that, and hopefully this works. Okay, so it works. Okay. In this case, what it's done is, if you know your JavaScript well enough, you'll know that even though date doesn't have an implicit toString, arrays do. So in this case, it's just taken our array, and it's done a toString, and it's just whacked it in there. We didn't have to do it in this case because, well, because JavaScript. Okay? But this doesn't look so nice. So let's go fix this up. All right, so let's say this.props.lunchChoices, and let's use a different variable so we don't get confused. We'll call this lunch options here. And inside of my application here, let's say, all right, so we're in the render block. We're before the return, which is essentially our UI definition is where we put the return block. But what we typically do is inside, again, of the render part or lifecycle hook, before the return block, this is where we typically put our UI logic. Okay? So I'll say we created this variable called lunch options. So let's go create lunch options equals, we're going to need our lunch choices. And then let's do a map around this. And let's say our lunch choices, nope, wrong button. I don't like the touch bar on this. So anyways, that's a rant for later. Okay. So let's say we'll call this just L for lunch options because we're lazy and we're just going to use that one thing. Let's actually make this a little smaller. There we go. A little bit more space. Okay, so we're going to say lunch choices map L. We're going to use a arrow function because we have to do less typing and it's just a function. And now what we'll do is we'll say return as we map over each one of those lunch options. Let's return a H3 with the L inside of it, right? Again, the L is each position as we map over our lunch choice array. Okay, so everyone following along with this so far? It's pretty simple, but just wanted to double check, okay? And we have our lunch options here, and let's see if that works. See if oh, that didn't work. Why didn't that work? Right, okay, good. I'm just making sure you're paying attention. Right, so we didn't put the braces around it, and oh, that's weird. Why did I just get L there? Curly braces again. Right, you learned this very quickly, actually. Okay, so there you go, okay? So now we're getting closer to creating a full component, but the interesting part about this last exercise is the way we think about constructing a React application, and specifically a component. We have our UI logic for the return block where we get stuff ready that we want to include in the UI definition, which is the return block. So in the return block is where we have, oops, wrong one. This is where we put our UI definition, right? Or this is how we conceptually think about this, okay? So we've created a component. What we can do in this case is say, you know what, maybe we want this lunch option thing is when we show it to be a little bit more sophisticated than what we have here. So let's create a subcomponent or another React component that will be used by this main React component called Hello World, right? So I'm just going to be lazy, and I'm just going to copy this guy, right? Programmer's best friend, Command-C, Command-V. All right, so we'll call this lunch options display or something. I don't know. We'll just leave it for that now. We don't need this const here. And how are we going to do this? So this lunch options display this component should only show a single lunch entry, and we'll put like some whiz-bang around it so it looks nice in a minute. So we don't need to iterate over this because this will be something that we use for a single lunch option. We'll keep this div here. We'll say H2. Let's get rid of this. Actually, let's get rid of all this. Okay, so we have a bare bones component here. And we're going to need to pass the data down into this lunch options display. Let's call this, let's name this a little bit better. Lunch option component. There we go. Now we're doing it right. Okay? So we're going to need to pass the actual data down from the parent component into this child component. So we'll do this.props.launch option. Okay? So let's save that. Let's see if we blew anything up. Nope, still works. Now let's use this new subcomponent we created. And instead of having this H3 and whatever here, what we'll do is we'll say, let's get rid of this H3 because we had our H3 or H2 or whatever down here. We're still going to need that L. And now we'll say, we'll use some JSX. We'll say launch option component. We'll close that tag because we're not going to include anything else inside of it. And then we'll say, what do we call the thing? We called it launch option without an S. Right? So we'll say, this specific launch option component should render with this data of L. Okay? And let's see if this works. Let's save this. And oop. Okay. Now it should work. Okay. Okay, so what we've done is we've created a subcomponent and used it in a parent component. And again, React is very much building out this component tree. So you build components, right? You won't have the components in the same file. So what I would do with this case is I would take this launch options component or launch option component and I would throw it into a file called launchOptionComponent.js, right? And then I would include that in my main component tree or wherever it needed to be included. So now I have this reusable component that can be used in different places. All right, so this is basic React properties, and we haven't gotten into state yet. All right, so let's see how we can incorporate or make this application a little bit better and think of state. Well, actually, let's go back to the slides. We'll come back and do some more live coding and get into state. But let's make sure we've covered everything that's important so far. JavaScript XML syntax, JSX. So there are a few quirks. Right, we've already seen this, so I'm going to skip it. There are a few quirks with JSX because we're including this HTML-like stuff inside of our JavaScript, right? So it does differ a little bit, but it doesn't really get in the way. It differs from HTML. Right? So for example, one thing that you can't do inside of JSX is use the word class. Right? When you're writing standard HTML, you use the word class to go and reference some CSS, right? So we can't do that. So instead what we have to do when we want to use one of the reserved words that don't work inside of JSX, so let's say that we have our launch option component, and let's say that we wanted to give it a class, and I'll just make something up, LO class or something, okay? So if I were to do this, React would be like, oh, I don't know what you're trying to do here. This is not going to work. What we have to do instead is we have to do this, okay? And the reason why class specifically is not available inside of JSX is because of this right here, right? Because class is a keyword in ES6 JavaScript, so you can't use class inside of JSX. You have to call class name. Okay, so there are little things like that that they don't really get in the way, but just have to be aware of. All right, so we talked about JSX. And there's some people who are like, well, I don't like this intermingling of HTML-like syntax with my JavaScript. So you could theoretically also write the same stuff that we've been doing by reaching into the React library and saying react.dom.h1 whatever, okay? So we could do this if we wanted to. All right, so we've already covered this. React.render component. Where do we render it? Where do we mount it? Or what are we rendering? Where are we mounting it? Into the DOM. We've created our own components already, right? This is, yeah, does anybody still have to use ES5 JavaScript, or is everyone on ES6? Anyone? Oh, a couple of unlucky people, okay. So you can use React with ES5 if you're stuck in the ES5 world for some reason. So instead of doing class, React component, et cetera, what you would do is you would say react.createClass, and that's the equivalent of the ES6 syntax that I showed a few minutes ago. Okay, so this is how we mount it. We've already discussed this. Now what I want to do is spend a few minutes talking, and don't worry about what's actually in the boxes here. The words in the boxes don't actually matter, okay? But when we think of a React application, we don't think of it as HTML and CSS, et cetera, et cetera. Yes, all that stuff is there. What we think about is we think of our component tree. As a React developer, we think, okay, I'm going to create this new application, or I need to go and update this application with this new feature. Where does that feature fit onto this component tree? when the user is actually using it. Right? So we have a tree, we have a root object at the top. Sometimes we can think of that as a top-level container, but we just call it a root object. And that root object will contain a menu bar, it'll have a main panel, that main panel will have a map panel, and then that will actually have a map inside of it, and then here's a table panel that contains more panels, et cetera, right? But the way that we conceptualize a web application when we're using React is from a component-oriented point of view. And this is the biggest jump that I had to make, because I've been doing web applications for a long time, and I think of the HTML, and I think of the CSS, and all these kinds of things. But when you're constructing a React application, we think in terms of a component tree, right? So this is the biggest thing that you have to kind of get your conceptual model right when you're building React applications. So if we were to add a new feature to this application, let's say that we need to add a third new feature, right? We have our map panel, we have our table panel, maybe someone from marketing says, wow, you forgot the About Us page on this web application, right? So something like that, I would put right under the top-level container so that we have a tab for menu panel, a tab for main panel, and then maybe an About Us or Contact Us widget that shows that specific information, okay? And say, as part of our map panel, we also wanted to add a search, that would be a child component of map panel and would be a sibling component of the graphical map, perhaps. Right? Anyways, the point here is not specifically this application, but those words were said so that you kind of get a better idea of how we think about the application. We think of it from a component-oriented point of view, and specifically a component tree. And in fact, this component tree should mirror what actually is in the DOM. Right? So because we create these React components, we instantiate them, we attach them onto the tree, and as we're doing this, those things will actually materialize in the web browser as UI widgets, right? We're coding all this stuff, so there's a parallel between what our React component tree looks like and what's actually shown in the browser, or specifically, what's actually in the DOM. All right. So we've already talked about dynamic components with attributes or properties. Right? We've run this example already. We have the this.props.name, and it doesn't have to be something simple. You can pass an array, a JavaScript object, whatever you want. Right, it just has to be JavaScript. We showed how to pass it down. We've already done some of the demo, but let's actually do another quick demo here before we get into state. Let's go fire up a little bit more complex application here. Right, I'm not going to try to live code this right now. Okay, so let's go here. And by the way, all these code examples, so this is a full 15 part or 13-part React workshop, and it's all available on my GitHub account. So you can go and actually play with this code and run through all the exercises. The slides are also available if you wish, okay? You're welcome to do that if you like. Okay, wow, this looks way better now. What happened, right? We're not just using plain HTML, okay? So this is one of the great things about this component-based architecture in React is that we can go and actually have, and let's make this a little bit bigger. Okay, can you all see that? Okay, yep, okay. Well, what we can do is we can actually find off-the-shelf libraries. One of the popular ones is called React Bootstrap. It's based on the standard Bootstrap 3.x library. And there's some other ones. There's something called Ant for React that has like nice UI widgets that you can just use off the shelf. So I didn't code any of this nice-looking stuff. I just used the React Bootstrap library. And you can see here in my imports here, I said import the Bootstrap. How many people have used Bootstrap? Pretty much everyone has at least seen it or worked with it, right? So this is basically the standard Bootstrap panel when you're just using the Bootstrap CSS library. But what some clever folks have done is they've taken the Bootstrap library and encapsulated them as native React components. So I'm importing the panel, I'm importing the label. There's some other stuff we could import as well if we wanted to. But you can see that I have the panel right here that I imported. That's what I'm using for the panel thing that's over here. And then inside, where am I using a label? There's a label used somewhere in here, but you get the idea, right? So I'm just using off-the-shelf library, and just like that, I have a really nice-looking component. All right, so now let's jump forward a little bit and talk about state and how state plays into a React application. Okay, I'm going to go into a different example. Make sure I got the right one. Okay, so this is lab number 8. Okay, so now we have our little lunch application rolling. Let's see what this looks like. okay? And you can see I have a couple of extra things here. But all this app is supposed to do is you're here at Jfokus, and maybe Matthias needs to know exactly what food to order, so we create this little application. And I feel like some fish on the first day, so you can't really see that. Let me make this a little bit bigger, okay? But you can see that as I click this thing right here is changing, right? So maybe I want vegetarian, fish, chicken, whatever, okay? So let's look at how this specific example is constructed and how we use state in this example, right? Those are the two key tenets of React programming. Well, you have components. You create dynamic React components using properties, and we also use state. And state is actually central in the React world. So let's have a quick look at this. All right, so we have our lunch options panel, which is this thing right here. And then we have a selected lunch panel, which is this thing right here. And what we're doing here is we're saying that when a user clicks one of these things, we're going to handle this click event by setting the internal state of this lunch options panel to be whatever they picked here, event.target.text content. We're just grabbing the text content. Typically for something like this, you'll grab something like an ID that you have for some data or whatever, okay? But we're setting the state here inside of this component. So this is a built-in thing in React, the state. You can see with the initial state we set, like so. We say state equals selected lunch, nothing selected. So if we go back and refresh this, you can see right here, it says nothing selected. That's our initial state for this specific widget. When the user clicks something, we want to put that into the state of the actual application. We do that by having a handle click. We say this.setState, the selected lunch, and you can see I'm using the same kind of data structure here, selected lunch. We go and just grab whatever the user picked and set that. And where is that state actually used? So we set the state initially here, and then we update the state when the user goes and picks something. So where is this actually used? Right, so we have our selected lunch panel, so it's actually being shown in a subcomponent, not in the component itself. So we have to pass that data down, but we grab that data, right? So here's our property, a usage of a property, but we say this.state.selected lunch. And that is initially this, and then when the user clicks on one of these things, we hit that handle click, and we update the state. And what that does is when we go and basically update the state, that tells React that, oh, something needs to change, because you've told me to update the internal data or the state in this application. So I'm going to go and render that component and all subcomponents. Okay, so that's how React works. That's how you create dynamic applications in React. When the user clicks something or they enter something into a search bar or whatever it may be, we want to go and update the state, and that is what triggers React to say, aha, you want me to go and take this new data, update the state, re-render this component and all subcomponents underneath it to reflect the new data, i.e. the new state that you have. Okay? So in this case, what happens when I click this thing right here, okay, and you can see here's where I have an on click, this dot handle click, it'll come into here, we have the event, we go and set the state, and once we finish this block of code, React says, okay, you asked me to go, you've gone and changed the state, that means I have to update the data everywhere in this component, subcomponent, so what it will do is it will re-render this entire thing with the new data that we're passing in here, with the new data that's here, okay? And that will cause this component, the lunch options panel, to update, and the subcomponent that we're using right here to also update, okay? So this is how we build React applications. We think of it as a component tree, and we think of our application as application state. We don't think of stuff, oh, I need to go update this specific H1 over here. No, what you think to yourself is, we have some new data from the server. I'm going to go and set the state with this new data that we fetched from the server in this specific component, and that will re-render that component and maybe a table component that's inside of it. Okay? So you can see we also can just keep state internally if we want. In this case, I say, all right, I want some chicken, and I want it extra spicy or something, I don't know. Okay, but you can see that as I type this, every time I hit a keystroke, this is getting updated. How does that work? We have this specific thing here. Again, we're going and updating the state with this update instructions callback that goes and sets the internal state of just this widget. And as I'm typing each word, it's actually re-rendering this thing every time I type something, okay? So you have to be, obviously this is not a best practice, whereas you're typing something else like every keystroke renders, you probably want to do something called a debounce so that when the web browser detects that, or your app detects that the user has stopped typing, it'll wait like half a second and then trigger a set state. Because every time you trigger a set state, you're doing a render and you're possibly updating something in the browser, okay? All right, so I have 5 minutes left, so we're going to just turbo walk through the rest of this. Okay, so real quick, the only callback thing that, or the only component lifecycle thing that we've used so far has been render. In React, we have about 7 or 8 different callback hooks for lifecycles for that specific application. So component will render, component did mount, component will mount, etc. And we use these lifecycles to do things to update that component or update other components or whatever it may be, right? The idea is that we have these hooks to be able to do stuff. So maybe if we change something in a component over here, this component way over here on the other side needs to get updated. How do we do that? Well, we can put some code into component did mount or component will render to say, go fire an event so that this other thing over here will go and get updated, but how does that other thing know that it needs to receive event? We would create a listener, for example, in component did mount to say, okay, attach a listener so that when we get the signal in the component, we'll go and do a re-render, whatever it may be. All right. So I want to finish off this discussion. All right, we talked about state. We have synthetic events, which are wrapping underlying things. I don't normally build web apps, but when I do, I use state. Right. So we talked about isomorphic. We got into browser. Right. As we make changes and instantiate components, the virtual DOM handles all the low-level performance management for us. So all we do is create components, and everything is great. All the performance and everything works really well. All right, so we're not going to talk about animations because we don't have time. But what I do want to spend the last few minutes talking about is this concept of one-way data flow. And this is something drastically different than what you have in the Angular world. In the Angular world, what we have is we have this concept of two-way data binding. So we create like a little text input button in Angular, and then we do a binding to some specific component or controller, right, or what we would consider logically to be a controller, and we bind those two things together. Right? That's what we do in Angular, not in React. And what happens is when the user clicks a button or enters something into this text area, because we have this two-way data binding, that goes and sends a signal to the controller, and then the controller says, oh, you've input something, I'm going to do something. And similarly, it's a two-way data binding in Angular. If you go and update something in that controller, it goes and pushes that data down into that widget or that view object or view component that it has. In the React world, what we think about is we think of one-way data flow. So what does that look like? Right, so this diagram is from the Flux architecture pattern for React. The basic premise is that we don't think in terms of data binding in React. We think in terms of flowing data down, specifically flowing state down from the top of our application down into components. Okay, user clicks a button, we need to go retrieve some data. So we have something that resembles an action that will go and say, aha, I'm going to go and get some data from our server. Now I need to go and send it somewhere, and we'll have something that may model a dispatcher, maybe not, right? If you're building a simple to moderately complex application, you don't even need a dispatcher. But you have some action that the user does, and we take that data and we flow it down to the specific React component that data is meant for. The user goes and inputs something into a search bar. We go and hit the API, we have the search results, and we flow the data down to the view. So it's a one-way data flow type of thing. In Angular and other frameworks, there's this two-way data binding where you have these actions or these events going back and forth between the view object or the view component and a controller. In React, we don't think of it in terms of that. What we do is we drop data in at the appropriate place on our component tree and let that data flow down into the view and into the specific React component and subcomponents that are mounted at that specific place. So in a lot of ways, thinking about our web application as three things makes life much easier. We model everything as cohesive components that contain the UI definition and the UI logic. We use properties to have dynamic components, and then we use state to set the data for our entire application, depending on what the user specifically is doing. And we flow the data down from the top. We don't have this two-way binding thing. Yes, when the user clicks something, we have to go and have a listener for it, or a click handler, or whatever it may be. But when that happens, we think of that almost as an external event. And we say, oh, we got this specific action or this specific click from this area or this component inside of our React application. That means I need to go get some search results, and I need to drop them into this place in the component tree. So we flow the data down one way. It makes conceptually modeling a web application much easier. We think in terms of data. We think in terms of state. The state of our application depends what our web app looks like and the data that the user sees on the actual application. So one thing that we can do that you can't do with other frameworks necessarily is say we want to do something like an undo, right? Maybe we've created a 5-step wizard for checking out a shopping cart or something like that. And the user says, yeah, actually, you know what? I don't want to pay with this credit card, or I didn't want to add that last thing into my shopping cart. Right? So what we can actually do is we can actually store the state of our application, right? Especially if we model it as a single like JavaScript object that keeps all the data in one place. We can actually just kind of keep the previous iterations or versions of our data, and we can just say, you know what, the user wants to go back 3 steps, let's save that data, we'll just grab it. User wants to undo, we just throw it into our React component tree, and just like that, we've been able to roll back without having to worry about what the state, what the UI looks like or what data is there, because we've kept it around. So doing undos is really easy. And the other thing with one-way data flow and using state for building a web application is that we remove the axis of time from development, right? So we don't really care like what time the user's in or what step the user's at. All we do is we say, the user wants to do this. This is what the data and the component tree should look like. Let's just throw that into the component tree, and boom, that's what we get. That's what the user will see. All right, so there are some frameworks that allow you to build this state-driven React application. Right? I don't think you should jump into the deep end of the pool immediately. If you're new to React, just start with basic React, learn, build basic or like a simple version of your web application. At some point in the future, you might need to use something that helps you do that state management. Right? Remember, React is about states and components. And the most popular library that you can layer on top of React for doing this is something called Redux. And there's also MobX, and there's several others. But the most popular are Redux and MobX, and they both implement the Flux architectural pattern for doing state-driven, one-way data flow web applications. Okay? And if you remember from the very first slide, I said that React only provides you the UI layer. So you do have to mix in other things. So eventually you'll need something like Redux or MobX to help you manage a more complicated application. Oh, you want to make an HTTP call to get some data? React doesn't contain that. So you'll have to grab a library like Axios or whatever to go and make that call and get that data. Right? So you have to layer these, or you have to add these libraries to fill out a complete React-based application. All right, and I'm 5 minutes past time, I know. I'm 5 minutes past time, so we don't have time for questions. But I'll be up front for a few minutes if you have any questions. Thank you for coming, and I hope you enjoy the rest of the conf.